Hi everybody. In this unit, I will be talking about what molar mass is and how to calculate it. You will need your periodic table along with a calculator for this lesson. Feel free to pause as you need. First off, molar mass. Molar mass is the mass of a mole. It's the amount of grams in 1 mole of a substance. So 1 mole not only equals Avogadro's number, which is 6.022 times 10 to the 23rd atoms, molecules, particles, etc., but it can also equal the mass of a substance. The units for molar mass is grams per mole. And how we find it is we must use our periodic table and use the average atomic mass found on the table for each element in a compound. So we must count the atoms in a compound and use the atomic masses found on the periodic table to figure out each atom's contribution. So hopefully you are on page 3 of your packet of fun. If not, please get to page 3 now. And I'm going to work through a couple of these with you. So again, molar mass is the amount of grams or the mass of 1 mole of a substance. And the units are grams per mole. All right. Notice how in the instructions it does say that we must include units. So here you just need to include units on your answer. Okay, so that grams per mole there as we calculate molar mass. So for our first one, lithium, it's just a single element. So if we look it up on our periodic table, lithium is right over here in group 1. It's an alkali metal. And the mass of it is 6.94. Now, since lithium's just alone in number 1, that's its molar mass. There's only one lithium, and each lithium has 6.94 grams of mass. So if we head back, then lithium's molar mass is 6.94 grams per mole. And that's it for the answer on that one. Now, they're not all that easy. So, of course, I'm going to work through a couple more with you, or maybe just like the next 2, and that's it. So when we calculate the molar mass of this one, and I am going to kind of zoom out here, we do want to take into account that we have 2 nitrogen atoms and 4 hydrogen atoms. So how I generally write this out is I'll write out like an N, and there are 2 of them. Hydrogen, there are 4 of them. And you want to multiply however many you have by the mass of each. So if we have 2 nitrogens, and then you look up nitrogen, if you take a look, nitrogen on the periodic table is right here, and each nitrogen weighs 14.01. And actually, I might try and side by side this. It might be a little easier. So each nitrogen is 14.01. So here we're going to be writing 2 times 14.01. And then for our hydrogens, we have 4 of them, and we want to multiply that by the amount of mass per hydrogen, which is 1.008. So 4 times 1.008. Now we have to calculate those 2 things and then add them up, and we'll get our total mass. Now, if you notice in parentheses here, I already have this number. That is the answer, but that's just to help guide you whether or not you're doing these properly. Like in number 6, it's a pretty tough one because it involves some parentheses there. So I gave you the answer for that one to show you whether or not you're getting it. So don't just stop here and assume you have it. Actually calculate it out to make sure that you're thinking about it in the right way. So 2 times 14.01 is 28.02. 4 times 1.008 is equal to 4.032. Now it's like a little addition problem here. I'll put the plus sign on the right side though, since I don't have a lot of room on the left. We simply add these two numbers together, and you should get 32.052. For the molar masses, I would say you could probably round it off at like 2 decimal places, so you could probably stop after the 5. I think in all of these, I just took it to the whole number. But yeah, you could probably take each molar mass. When we are actually using it in conversions, you can probably take it to 2 decimal places. Okay. Some people like to use the whole number because then your answer is more exact, because technically you should not round until the very end of a calculation anyway. All right, so let's take a look at one that's a little bit more difficult. Oh, sorry, we forgot something here. Oopsies. We forgot to put our unit, grams per mole. Now, let's go to number, there was one with this one, number 6. So we do have to count atoms, kind of like when we were balancing, except instead of balancing, we're just adding up the masses of everything. So, but we have to keep the same idea of how we count atoms. So for this one, in this compound, we have a zinc. Oops. Let me zoom in over here. All right, so we have zinc, phosphorus, and oxygen. Now, there are many ways that like you guys can decide how you're going to do this. For instance, if you wanted to find the mass of an entire PO4 and then multiply that by 2, you could do that. I always count up the atoms. So here we can see, because of that subscript on the zinc, that there are 3 zincs. And then for the phosphoruses, if we have 2 PO4s, treat this like math class, where the number outside the parentheses goes to everything inside the parentheses. So if we have 2 PO4s and each PO4 only has 1 phosphorus, that's 2 phosphoruses total. And then for the oxygens, if we have 2 PO4s, then you have 2 O4s. So you would multiply that 2 and that 4 to get the total number of oxygens. So we have 8 oxygens in this one. And then you want to look these things up on your periodic table to determine the masses and then calculate them out. So zinc is 65.38. Phosphorus's mass, here it is 30.97. 30.97. And then oxygen's mass, is an even 16. So 8 times 16. So you would want to calculate all those out, add them up, and then hopefully you get that answer. I'm not going to do that with you. I just wanted to show you the process of getting it. But that is how you find molar mass. At the bottom here, don't get too in a tizzy. So instead of giving you the formulas, I've simply just drawn out the Lewis dot structures. So for this one, you have 1 silicon and 4 hydrogens. This is SiH4. Over here, it does have a negative symbol, and over here, this one does have a positive symbol, but again, mass is always your protons plus your neutrons. So you don't even have to worry about that positive and negative. You're just counting atoms and then determining their masses and adding them all up. And that is how you find molar mass.